On the screen we have a pump performance curve at 50 Hertz. What are the implications of running this pump at 60 Hertz?
Okay, let me start by saying that most standard pumps that you buy in the marketplace in Australia are basically global supply products. So they have been initially designed for operation in countries like Japan and USA, where they have 60 cycles as standard. So that's the normal frequency of the electrical supply. So most pumps and most electric motors are actually suitable for operating at 60 cycle speeds. So 60 cycles shouldn't be a limitation in terms of product selection. What you then have to do is to match the performance of the pump to the load profile. And if you operate 90% of the time at what you might call the normal operating point, and occasionally you have to increase the flow by 10 or even 20%, you could use that frequency change as a way of dealing with that situation. So if you increase the frequency from 50 to 60, there are no impacts on the product. The pump performance should increase by approximately 20% on flow and approximately 140% on head. So you'll get an immediate improvement in terms of pump output. But you will also get an increase in the kilowatt demand. You've got to take all of those things into account when you're looking at the bigger picture of how do you match the pump performance to the total system requirements at various load profiles.
Follow-up question, why is it that the industry has adopted designing pumps around 50 Hertz only?
That's a difficult question to answer on behalf of somebody else, but my view is that's because they are trying to build in margins for error. A pump is designed and performance curves are based around 4-pole and 2-pole speeds. Those are the normal pump curves that we play around with. So 4-pole speed gives us basically 1450, which in a 60 Hertz environment is going to give us 1750, something of that order. Now we can use that margin for error in the additional cycles rather than dropping the frequency down in the normal operation condition. So maybe people are not aware that pumps and motors will run at 60 cycles and drives will run at 60 cycles. Therefore, they're not taking it into consideration in their design philosophy. The other thing that might be influencing them is that some of the older pump specifications mention maximum speed 1500 RPM. Now, 1500 RPM is related to a 50-cycle country. And if that's in the specification from when the partners originally wrote their pump spec, that would rule out operation at 60 cycles, wouldn't it? Because 1500 is not a 60-cycle speed for a 4-pole motor. So you've got those two influences from my point of view. The first one is margin for error, because nobody correctly calculates the duty of the pump in this day and age. And secondly, the fact that a lot of people are working with that 1500 RPM limitation from old pump specs.